Does the universe hide secrets far beyond our understanding, buried in the depths of space? Dear traveler, welcome. Today I'd like to invite you to don your spacesuit. We're going to sail through interstellar space, which in defiance of the standard model, conceals many anomalies. Although the universe that surrounds us leads us to believe that everything is methodically organized, like a musical score, without a false note, you're going to discover that certain proven facts go against certain rules that seem indisputable. Could these anomalies, which are anything but fleeting, revolutionize our current science, leading to the emergence of new models? That's what we're here to find out. But before you set off on this fabulous expedition, if you haven't already done so, remember to like the video and subscribe to the channel so you don't miss a thing. Thank you, and have a great trip! With the help of the Hubble Space Telescope, which probed space in the second half of the 20th century, astronomers attempted a daunting challenge: to draw a map of the cosmos, locate our solar system and the Milky Way in the universe, and predict their direction. Although Albert Einstein presented his theory of general relativity in 1917, suggesting that the universe was static and bounded, he was forced to admit his error 10 years later. In 1929, the Hubble-Lemaître law, predicted 2 years earlier by Lemaître, demonstrated that our universe is in continuous expansion, and what's more, at an insane speed. Like all galaxies, our Milky Way is caught up in a cosmic flux, triggered by the Big Bang. Since then, the early universe has expanded in all directions and at an ever-increasing speed. As a result, the distance between all galactic structures is growing ever greater. Like splashes, we imagine that galaxies move at similar speeds on either side of their starting point. But this is not the case. The force of gravity drives many objects to gather into clusters and superclusters. It precipitates the local cluster, the group of galaxies to which we belong, at over 2 million kilometers per hour, or 1.2 million kilometers per hour, in the direction of the Virgo cluster through the immense Laniakea group. In the 1970s, observation of their motion revealed that the expansion of the universe was not uniform. A deviation, reflected in variations in the offsets between certain galaxies, between minus 700 kilometers per second and plus 700 kilometers per second, or minus 430 miles per second and plus 430 miles per second, highlighted an anomaly. The local group, among others, is deviating from the general expansion of the universe at a speed of 366 kilometers per second, or 227 miles per second, in the direction of the Centaur. In the deep cosmos, somewhere in the fuzziest zone of space, masked by our galactic plane, an invisible magnet seems to be drawing us into its meanderings. But this massive gravitational irregularity doesn't just affect the Milky Way. It attracts thousands of other nearby galaxies. This anomaly has been dubbed the Great Attractor. Its location, determined in 1986, places it between 150 and 250 million light-years from the Milky Way, in the direction of the Southern Triangle and Ruler constellations. With its colossal force, attributed to a mass estimated at several tens of millions of billions of solar masses, this anomaly appears to operate from the gravitational center of the Laniakea supercluster. Above all, it has the ability to attract galaxies within a radius of around 300 million light-years. Despite technical innovations in astronomical observation, this superstructure remains an enigma. For some, it could be a confluence of dark energy, attracting to itself any galaxy close enough. For others, the anomaly could be the result of overdensity, a zone of very dense mass generating an intense gravitational attraction. The beginnings of an explanation emerged in the early 1980s, thanks to an international collaborative study. The largest concentration of large-scale matter in the near universe was detected in this hidden region of the cosmos. Known as the Shapley supercluster, this structure, of 44 clusters totaling 8,000 galaxies, spans more than 120 million light-years and weighs approximately 10 million billion suns. But the discovery of this megastructure is not enough to explain the anomaly. Although it has a staggering mass, it is only half of that needed to draw us to it. What's more, it seems to be located behind the Great Attractor, which still remains a mystery. But it's not just cosmic objects that are subject to the sometimes puzzling temperament of the universe. In the early 70s, 2 space probes were launched, with the mission of making an initial reconnaissance of the planets of the outer solar system. In 1972, Pioneer 10 was the very first spacecraft to break free of the asteroid belt and fly past the planet Jupiter before reaching the liberation velocity required to leave the solar system, followed by Pioneer 11. The second probe took the opposite direction the following year, heading for Saturn after a close study of the Jupiter red spot. Unexpectedly, as the probes moved away from the Sun, an invisible force seemed to hold them back in their respective launches. The appropriate model, taking into account all the effects that could influence the speed of this type of craft in interstellar space, turned out to be wrong. As early as the 1980s, astrophysicists noticed that their speeds were steadily decreasing, despite their opposing trajectories. Although the probes had fulfilled their mission, their observation was continued over time, using the Doppler effect. For a long time, this phenomenon was downplayed as inherent to the probes themselves. Fuel leaks could have affected the probe's orbits. Or has the impact of radiant heat from the plutonium used, or of light on the solar sails, been underestimated? For some scientists, Newton's theories and Einstein's relativity are being called into question. This suggests that gravity could imperceptibly gain strength over enormous distances. But if so, why don't the planets themselves seem to be affected? In any case, the behavior of the Pioneer 10 and 11 probes continues to intrigue scientists. Delayed by 500,000 kilometers, or 310,000 miles in recent years, these 2 spacecraft have helped detect this anomaly, which, if not elucidated, could well upset the foundations of current physics. But before we enter our hibernation chambers and drift off into a deep sleep, let's take a closer look at one of Saturn's moons. Behold Titan, the only known cosmic object to exhibit a stable liquid surface mass. This feature, though extraordinary, is not the only one this satellite possesses. Even more disconcerting, near its north pole, in Titan's second largest sea, called Ligeia Mare, a luminous object seems to be playing hide-and-seek. Sometimes visible, sometimes nowhere to be seen, unlike its direct vicinity, this zone was explored as early as 2004 by NASA's Cassini probe. But it was in July 2013 that it was first spotted in images from the same probe, before disappearing again a few days later. The area, estimated at around 260 square kilometers, or 160 square miles, finally reappeared in images dating from August 2014. To everyone's surprise, its appearance was different from that observed 2 years earlier. Is it an object floating on the surface of the sea, which for some unknown reason remains static? Or is it simply a change in the landscape, suggesting the presence of dynamic geological mechanisms in Titan's atmosphere? Researchers have put forward several hypotheses about the nature of this strange island. It could be caused by waves linked to an atmospheric phenomenon, or it could be composed of gas bubbles emanating from the depths of this liquid expanse. The appearance could also be explained by the formation of methane ice, or even an increased concentration of suspended particles, such as silt floating between two levels of water. But for some scientists, these extraordinary changes on the moon's surface are akin to the seasonal changes on Earth. Indeed, they have noticed that this mysterious island has always revealed itself at the beginning of summer in the northern hemisphere. It could, therefore, be linked to seasonal events, but over a longer period than our 4 seasons. As you can see, it's not only nature on Earth that has some surprises in store for us. This discovery, like a waking dream, brings us back to our collective phantasm, finding another habitable planet. Our sidereal journey now takes us to a strangely dark area of space. I invite you to step out of your chamber and let yourself be absorbed by this strange universe, virtually devoid of any visible matter. Faced with this enveloping, even deafening blackness, the surprise is total. Here you are in the middle of nothing, or almost nothing. But don't panic. Don't let this frightening environment overwhelm you. We're not sinking into an endless cosmic hole. Although space seems to be dotted all over with objects of varying luminosity, there are a few vast places where, strangely enough, emptiness dominates. We're currently right in the middle of one of them. It's the local hole, also known as the Keenan-Barger-Cowie Void, or KBC Void. This structure, or local subdensity, is no more and no less than a vast expanse, where matter has a density around 20% lower than the average of the observable universe. Studied in 2013 by 3 astronomers, the local hole closely resembles a sphere, around 2 billion light-years in diameter. And I'm going to surprise you. This cosmic void isn't as empty as it looks. I could even say that your cosmic address depends on it. In fact, it contains most of the Laniakea supercluster, including the local group, and consequently, the Milky Way. Our Sun is only a few hundred million light-years from the center of the local hole. Here's another piece of information that's sure to baffle you. Cosmic voids like this one exist in dozens of other, less exceptional dimensions. The only cosmic void larger than the local hole is nearly 3 billion light-years across. Thus, when observed on a very large scale, the universe resembles a cheese of holes, with zones rich in matter and others largely empty. Our galaxy and its wider neighborhood are therefore evolving in an immense empty bubble. According to the cosmological principle, the distribution of matter throughout the universe is fairly homogeneous, even over vast observed areas. While this can be confirmed on scales of around 250 million light-years, when we look at even larger regions, these cosmic holes appear. But what's even more interesting is that these voids could explain the discrepancy in Hubble constant measurements. Indeed, depending on the observational methods used, the expansion velocity of the universe presents contradictory values, known as the Hubble tension. The velocities of thousands of galaxies just located and counted were found to be 10% higher than those predicted by the lambda cold dark matter model. Makes you wonder whether the standard lambda cosmology model is really reliable, doesn't it? Could it be that unknown forces or manifestations are influencing our universe? This could explain why the model's predictions turned out to be wrong after these observations. The KBC vacuum is therefore a density anomaly, which, in addition to challenging our current understanding of the dynamics of our universe, could provide the beginnings of an explanation for some major inconsistencies. Scientists at the University of St. Andrews recently put forward a hypothesis. The velocity fluxes of galaxies, i.e., the speed at which they move as a group across the universe, would naturally be higher in and near this cosmic void, rather than in constant acceleration. They suggest that galaxies located within, or relatively close to this void, would exhibit higher velocities due to differences in matter density and consequently discordant gravitational forces. In short, local variations in the expansion rate of the universe would be related to Newton's laws of gravity, which are supposed to apply uniformly throughout the universe. Thus, according to their theory of modified Newtonian dynamics, MOND, regions similar to this void would experience a weaker gravitational force, resulting in greater velocity. If this explanation proves relevant, in addition to challenging the foundations of gravity theory, it could mark the beginning of a new age in cosmological research. Your hibernation chamber, programmed to bring you gently back to a state of wakefulness, has just opened. Your eyes are immediately drawn outwards by countless luminous galactic filaments. Here we are, close to the largest superstructure in the universe known to date. You're looking at the Great Wall of Hercules' Crown Borealis, also known as the Great Wall of Hercules' Corona Borealis. This gigantic group of galaxies lies around 10 million light-years from our Sun, in the constellation of Hercules and Corona Borealis, as its name suggests. Its discovery, which dates back only to November 2013, can be explained in part by its remoteness. Scientists spotted it by mapping gamma-ray bursts, the dazzling explosions of the most powerful stars in the cosmos, far away and massive. But they had to be patient. Indeed, these explosions, which release more energy in less than 1/10 of a second than our sun will produce in its entire existence, are extremely rare. In an ordinary galaxy, explosions of this type occur only exceptionally, at the rate of one every few million years. The stars that cause these cataclysms are very massive, requiring large quantities of matter for their formation. If these explosions can be used to pinpoint a galaxy or a large body of matter, they need to be the subject of lengthy study, involving the recording of colossal quantities of data. This is what astronomers set out to do, mapping these luminous phenomena from 1997 to 2012. To do this, they used the Fermi and Swift robotic satellites. The latter were designed to detect gamma-ray bursts by measuring their redshifts. The study of the data collected paid off. The map drawn up over 15 years of observation revealed 14 gamma-ray bursts with redshifts. What's more, these similar explosions were very close together. For scientists, there can be no doubt. This far-flung region of space is home to a very large group of galaxies and large quantities of matter bound together by gravity. According to their estimates, this structure, home to billions of galaxies, seems to measure 10 by 7.2 billion light-years. However, while it covers just over 10% of the diameter of the observable universe, it is only 900 million light-years thick. Until now, the largest observable structure in the universe was represented by the group of large quasars, measuring 4 billion light-years. To give you a better idea of these unusual dimensions, remember, our galaxy, the Milky Way, measures just 100,000 light-years in diameter and is only 2.5 million light-years away from its nearest neighbor, the Andromeda Galaxy. But how does this discovery fit in with the list of space anomalies? To cut a long story short, the Great Wall of Hercules' corona borealis doesn't fit in with the principle of cosmology, Albert Einstein's famous theory mentioned earlier. According to this principle, the entire universe is isotropic. Cosmology therefore stipulates that the universe is the same in all directions, spatially homogeneous, and similar at every point on a scale of several hundred million light-years. Thus, scientists who assume that matter has been evenly distributed since the creation of the universe predicted that no structure could be larger than 1.2 billion light-years. However, the Great Wall of Hercules' corona borealis is 8 times larger than this supposed limit, calling this cosmological principle into question. What's more, this imposing structure contradicts theories on the evolution of our universe. This glittering wall you can admire is some 10 billion light-years away from our Earth. This means that terrestrial observers have seen this structure as it existed 10 billion years ago. The famous Big Bang at the origin of our universe occurred 13.8 billion years ago. This difference is far too short. How could such a gigantic structure have formed in just 3.8 billion years? The existence of such a structure remains a mystery to astrophysicists. With their current understanding, they are unable to explain how it could have formed in such a short space of time. The Great Wall of Hercules' corona borealis could well compromise the veracity of the Big Bang theory. As their discoveries continue, astrophysicists are constantly adding to their list of enigmas to be solved. One of them is to explain the presence of rings around objects that shouldn't have them. As a reminder, only Saturn, Jupiter, Uranus, and Neptune, the giant planets, were equipped with these attributes in our solar system until this unexpected discovery. Introducing Chariklo, an asteroid discovered in 1997 that orbits more than 2 billion kilometers, or 1.2 billion miles beyond Saturn's orbit, deep in our solar system. While it is the largest member of the Centaur asteroid class, with a diameter of 302 kilometers, or 188 miles, it has been favored by many observers since 2013 for its astonishing peculiarity. This asteroid, around 50 times smaller than the Earth, has 2 rings. See how dense and narrow they are. Estimated at just 5 kilometers or 3 miles wide, they orbit at an estimated distance of 400 kilometers or 250 miles from the primary object. It is the smallest celestial body encircled by rings discovered to date. But it's not the only one. In 2017, a second such discovery was announced, this time concerning a small planet in the Kuiper Belt. Look at this piece of rock showing off its rugby ball appearance. It's Haumea, a dwarf planet averaging 6.5 billion kilometers, or 4 billion miles from our Sun. While trying to determine the size of this object, detected in 2004, astronomers discovered its particularly dense equatorial dust ring. No fewer than 12 telescopes pointed their lenses in Haumea's direction as it passed in front of a star, the ultimate condition for determining its dimensions. But to the great surprise of the researchers, a rapid extinction preceded the passage of this dwarf planet in front of the luminous star. They were able to establish that this dwarf planet, with a diameter approaching 2,000 kilometers, or 1,300 miles, is surrounded by a fairly narrow ring, around 70 kilometers, or 44 miles, but particularly dense, which orbits it at a distance of around 1,000 kilometers, or 620 miles. No explanation has yet been found for the origin of this ring. Is it an ephemeral phenomenon, or is it long-lasting? What is certain is that this anomaly could indicate that rings surrounding dwarf planets may not be as rare as scientists previously thought. In fact, an even more sensational discovery was made in the following years. This time, a ring was detected near an even more distant trans-Neptunian object. Meet Quaoar, a dwarf planet whose ring is not only unpredictable but also curiously located, hence its late discovery. In fact, Quaoar was discovered in 2002, while its ring was only recently detected and revealed to the public in February 2023. Quaoar was discovered by a team of American astronomers during Caltech's large-scale sky survey. As they surveyed the Kuiper belt for the brightest objects, their attention was caught by a dark object of apparent magnitude 18.6. It was moving slowly in relation to its background, a cloud of distant stars. Scientists call this phenomenon occultation. Its diameter, quickly estimated using data from the Hubble Space Telescope, is around 1,110 kilometers, or 690 miles, giving it the status of a dwarf planet. It is also one of the largest objects in the Kuiper belt. In addition to its size, this dwarf planet has a satellite. It's a moon, about 170 kilometers or 105 miles, called Weywatt. But what's even more incredible is that this small planet, which orbits our Sun at a distance equivalent to 43 times that separating the Earth from the Sun, is surrounded by an extraordinarily distant ring. With a radius of 4,100 kilometers or 2,600 miles, it lies well beyond the Roche limit, defying previous models for the formation of such a structure. No other ring has ever been detected so far from its planet. This one is more than 7 times its radius, marking the boundary of the Roche limit. According to this model, a ring could not exist beyond 2 to 3 times the radius of the central body. This discovery is an anomaly for scientists, running counter to the above-mentioned model, whose origin lies with astronomer Edouard Roche. The rings are not supposed to exist in such a remote perimeter. The particles of matter present in this zone should have agglomerated with each other, since they are not subject to the tidal effects produced by the main body, which are greater than the gravitational cohesion forces taking place between them. And yet, despite being outside the Roche boundary, these numerous pieces of debris don't seem to be undergoing this long agglomeration process at all. So how does such a ring manage to endure over time? Here's one more mystery for astrophysicists. The icy temperature of the ring's debris could provide the beginnings of an explanation. Some scientists believe that the ice particles undergo so-called elastic collisions, preventing them from sticking together. So what you have before you is an exceptional, unusual, even inexplicable ring, at least for the time being. Admittedly, it doesn't have the splendor or grandeur of Saturn's rings. Nevertheless, its position in relation to Quaoar makes it unique, especially as it hides the secret of its very existence for the time being. But how about a little rest? After observing these anomalies, each more disconcerting than the last, a good night's sleep will enable us to tackle the next stage of our exploration with slightly clearer skies. The next time we wake up, a new surprise awaits you. Look at this exceptional star. This is Tabby's star, one of the most mysterious and exciting stars in the Milky Way, just 1,470 light-years from our Sun. Tabby's star, which cohabits in the constellation Cygnus alongside numerous other luminous objects, stands out from its companions in a singular way. Although first detected in 1890, Tabby's star has been the subject of particularly close study in recent years. The reason for this is its unusual light fluctuations. While the Kepler Space Telescope recorded variations in the brightness of over 100,000 stars in the Cygnus and Lyra constellations, data collected between 2009 and 2013 led astronomers to take a closer look at this star. For scientists searching for exoplanets, the brightness fluctuations recorded are unmistakable. There is probably a large mass, or many small masses in close formation, in its vicinity. This is why there is so much interest in this star, potentially accompanied by an exoplanet. Observations show that the star displays an atypical light curve for a number of reasons. It shows both periods of deep decline and long-term changes. On several occasions, its brightness has declined to as much as 22% of normal. What's more, a study of the archives revealed that this seems to have been happening repeatedly over a number of years. Now, if a planet the size of Jupiter were to occult this star, not only would it lose no more than 1% of its brightness, but more importantly, these changes in brightness would be cyclical. Except that, in this case, the fluctuations are totally random. Scientists then speculated that it could be an occultation linked to a random phenomenon occurring between Tabby's star and the observation zone. But this hypothesis doesn't hold water, especially as periods of significant brightening have also been recorded. I'm not going to hide the fact that the idea of an extraterrestrial megastructure has occurred to a few followers of this dogma. A Dyson sphere, set up by an alien civilization, would then be able to appropriate some of this light to meet its energy needs. But this idea was dismissed as preposterous by most. In fact, as you can see, there's no sign of any unknown technology being installed. But then what could be blocking the light from this star during the darkening phases we've noticed? The most simplistic hypothesis suggests that irregular dust clouds or orbiting debris could explain this phenomenon. However, the researchers noted that the infrared wavelengths of light pass through the gradation more easily than the ultraviolet bands. For them, this observation rules out the possibility of a solid object. Could it be the debris of an exoplanet? Or an exolume torn apart by the star? Or could it be several groups of comets sailing alongside it, like swarms of bees? Or are they inherent fluctuations of the star itself, like the famous Betelgeuse? But in that case, why these versatile variabilities? Could it be that the star is undergoing a natural process that means it has reached a critical stage of phase transition? Whatever the case, in order to unravel this mystery, scientists need to be sure of one thing. If it's an interference due to the superposition of an occulting material, they'll have to confirm its circumstellar nature, and then its nature. If this is not the case, new alternative models for starlight could be developed. And what about you? What's your opinion on this anomaly? Just a stone's throw from this star with its strange behavior, we broach the subject of extraterrestrial entities. This must remind you of an unusual phenomenon you've probably heard of, still considered an anomaly for want of a plausible explanation. On October 19, 2017, a mysterious object was spotted as it passed through our solar system, baffling astrophysicists for many reasons, with some even considering the possibility of extraterrestrial technology coming to visit us. This fabulous object was detected by Hawaii's Pan-STARRS telescope and christened Oumuamua, scout or messenger in the Hawaiian language. Its hyperbolic trajectory and unusually high speed led to the conclusion that it came from another star system. Coming from who knows where, this bolide was the first interstellar object to visit us so closely before continuing its long journey to an unknown destination. With its cigar-shaped ship-like appearance, it brought to mind certain cinematic images, often ominous. As you can imagine, this interastral intruder did not go unnoticed for a number of reasons. First of all, its dimensions. Measuring in length between 200 and 400 meters, or 600 and 1,300 feet, with a width 10 times less than its length. What's more, the object's brightness and variations in luminosity could lead observers to believe that it was a metallic object rotating on itself. Once again, science fiction films are full of spaceships based on similar movements. Its appearance wasn't the only thing that puzzled scientists. Its attitude proved just as disconcerting. While from a rational point of view, it resembled an asteroid or comet, it displayed neither the sparkling tail nor the halo usually attributed to the latter. Even more disconcerting was the way it crossed our solar system. When it was detected at a distance of around 30 million kilometers, or 19 million miles from the Earth, its speed was estimated at 50 kilometers per second, or 31 miles per second. Then, as it drew closer to our Sun, it accelerated progressively until it reached 87 kilometers per second, or 54 miles per second. But perhaps the strangest thing about it was its rocket-like behavior. Indeed, after orbiting the Sun, it experienced an extraordinary acceleration as it changed its trajectory. At that very moment, it was traveling at a speed of over 300,000 kilometers per hour, or 185,000 miles per hour, heading for the constellation of Pegasus, before finally exiting our solar system. Scientists theorize that such a brief visit by such a cosmic object could have been the result of a spacecraft. Could it have been a simple asteroid, an atypical comet, a hydrogen iceberg, or the debris of an exoplanet? Naturally, researchers tried to unravel this mystery by mining the data collected, specifically those concerning this fabulous acceleration coupled with an improbable change in its trajectory. Neither a gravitational kick from the Sun nor an outgassing phenomenon seem to explain this supernatural behavior, contrary to the laws of physics. What's more, no unusual radio emissions were detected during the same period. Since 2019, a study by the Astronomy Department of the University of Maryland has settled one point. The object did not originate from an alien entity, and its natural origins were justified. According to a study published in Nature magazine in March 2023, it is a water-rich object, similar to a comet that has undergone significant weathering. It reports that Oumuamua, like comets, is essentially composed of water and rock. The object would have been propelled far from its star's gravitational grip before drifting off into interstellar space. During its long cosmic wanderings, it would have been bombarded by cosmic rays, particularly energetic particles that can penetrate dozens of meters beneath the ice. According to one model, more than a quarter of the water molecules present on Oumuamua were transformed into molecular hydrogen, which was then trapped in countless small pockets of ice. When the object got close enough to our Sun, at a distance of tens of millions of kilometers or miles, the hydrogen ice would have undergone a sudden change of state, transforming into gas. By escaping on its own, the hydrogen gas would then have propelled Oumuamua, causing the abrupt change in direction observed. This hypothesis, which holds true for many scientists, helps explain why no halo or streak was detected by telescopes in 2017. The exact nature of Oumuamua cannot be certified to this day, leading, as you've seen, to major discrepancies in the sphere of astrophysicists. This object has definitely left our solar system, taking with it a mystery that will never be solved. However, future observations by the Vera Rubin telescope in Chile, due to begin in 2025, could well change all that. Designed to detect new comets, both inside and outside the solar system, it should be able to collect relevant data on them. If, like Oumuamua, the smallest comets show signs of releasing trapped hydrogen and do not display a characteristic tail, then the existence of this new type of comet could be confirmed. How about that? Our onboard computer reports that it has recorded a radio signal that seems to be repeating itself on a regular basis. Let's take a closer look. The transmission comes from the constellation of Sobieski's Shield, east of the tail of the serpent. The ground team confirms that they too have detected this unusual signal. They tell us they've observed the signal lasting from 30 seconds to 5 minutes, repeating itself strangely, slowly every 21 minutes. Our cross-reference data indicates that we are indeed interested in the same phenomenon. What could be behind such a radio source? Could it be an extraterrestrial radio signal? Of course it could. But let's not panic. This signal mustn't be perceived as a threat. Let me explain. This intriguing radio signal was first detected in 2022 by Australia's Murchison Wide Field Array Radio Telescope, before being observed and then confirmed by numerous other facilities worldwide. In a study published in July 2023 in the journal Nature, researchers from Australia's Curtin University report their findings. Although they are not yet in a position to catalog the object perfectly, they do offer some explanations. It turns out that this extraterrestrial signal is emitted by an astral object named GPM J1839-10. Yes, you heard me right. It's coming from a star, not from an entity potentially in search of traces of distant life. However, this stellar object, which behaves like a pulsar or magnetar and is located 15,000 light-years from Earth, has left scientists stunned. Radio signals from such stars, sweeping across our Earth on a regular basis, are nothing out of the ordinary, you may say. And yet, there's nothing coherent about this one. As you probably know, magnetars, or dying stars, produce energy at regular intervals. These neutron stars, with their extremely powerful magnetic fields, are particularly dense, rapidly rotating objects. The flashes they produce last only a few milliseconds, rarely more than a second or two, and are repeated at a steady rate of no more than a handful of minutes. In this particular case, let me remind you that the powerful radio beams detected last up to 5 minutes and are repeated only every 21 minutes, which is inexplicably slow for such an object. Such periodicity has never been observed before. Could it be that scientists have spotted an exotic object never before discovered? Subsequent study of the telescopic archives revealed another fact about these enigmatic radio wave emissions. The scientists, totally baffled, asserted that these have been recurring since at least 1988. This means that the star has been transmitting in this way for over 35 years. In January 2022, the discovery of a similar object, J1627-5235, was also announced. This transient object also emitted strong radio emissions lasting 60 seconds and recurring every 18 minutes. However, according to recent monitoring and archive data, its radioactivity was short-lived compared with that of its counterpart. It lasted just 3 months out of 8 years of observation. If it is indeed a magnetar, such a discovery calls into question current knowledge of this class of neutron stars. As they age, their magnetic fields gradually weaken, inevitably slowing down their rotational speed. Then, when they reach the death line, the threshold at which they can no longer produce high-energy emissions, they fall silent forever. In our case, however, this limit has been well exceeded. Nevertheless, this beam of radio waves continues to rotate, like a tireless cosmic beacon. Scientists believe that it could be an extraordinarily slow magnetar, or even a white dwarf radio pulsar, but one thing is certain. Even if one of these two hypotheses proves to be correct, both involve numerous parameters and uncertainties that remain to be elucidated. Let's add this new anomaly to the many other cosmic mysteries and continue our journey. Let's make sure everything's okay, shall we? What are you staring at? What are you saying? A curious circular mist? Yes, it is. Our radio wave measuring equipment is categorical. Straight ahead of us stands a strange ring of cosmic smoke. Its ghostly appearance partially obscures the stars in the background. If we were observing it through a telescope, I'd certainly advise you to clean your lens. A priori, this enormous structure, large enough to contain entire galaxies, is only detected in the radio range. None of our other measuring devices seem to perceive it. This reminds me of a recent discovery. I think we're looking at an odd radio circle, or ORC for the more erudite. The first such object was detected in 2019 by astronomer Anna Kapinska. When she presented this image to Ray Norris, a science professor at the University of Sydney in Australia, she named it WTF, for what the fuck, which shows just how disarming, even frightening, this discovery proved to be for her. Before publishing the result of this astounding discovery, the astronomers preferred to wait several months. In particular, they wanted to be sure that the signal detected was not an astronomical mirage that could be attributed to the measuring equipment. Further data collected by an Indian radio telescope confirm this unusual discovery. No plausible explanation for this strange radio circle, which resembled a ball of smoke, could be found. For some, this puzzling phenomenon could be linked to a wormhole. For others, it could be the result of an explosion in a deep space galaxy, or a collision between a powerful neutron star and a black hole. Just a few days after this exceptional discovery, a second strange radio circle was detected, proving that this was not a unique case. To date, only 11 strange radio circles have been spotted, but researchers believe that thousands more could well be discovered in the not-too-distant future. However, observing them is proving very difficult. These structures, although colossal, with a diameter of several 100,000 light-years, 10 times wider than our own Milky Way, are billions of light-years away. What's more, as mentioned earlier, they emit light only at radio wavelengths. Since then, Ray Norris and his team have taken a very close look at the very first strange radio circle discovered. To do so, they used the Meerkat antenna array at the South African Radio Astronomy Observatory. With 64 domes, each measuring 13.5 meters, or 45 feet in diameter, this is the world's most sensitive and precise radio wave equipment. The anatomy of this foggy ball has been revealed to scientists, revealing itself to be far more complex than presumed. The spherical structure is made up of several intersecting arcs. Above all, at the very heart of this system, a tiny dot has been spotted. It is possible that this dot, which also appears in images taken at other wavelengths, is an immense elliptical galaxy. For the researchers, there's almost no doubt. These two elements, the strange radio circle and the galaxy, are linked, the latter probably being at the origin of this anomaly. But how? The origin of this huge ring of radio waves remains a mystery, and various hypotheses are being discussed. The first suggests that the galaxy in question experienced a period of intense star formation. Their successive cataclysmic births and deaths would have violently pushed back the surrounding gas and particles, triggering an expanding shock wave. The second theory suggests a collision between two supermassive black holes located in the interior of this galaxy. This strange radio circle would then be a shell formed by outgoing galactic winds. This scenario, if it exists, has never yet been observed, although it is one that greatly arouses the curiosity of astrophysicists. Finally, others believe that we are simply looking at the barrel of a powerful jet, emerging from the active nucleus of this same galaxy. As the exact origin of these strange radio circles remains unresolved, I suggest we divert our trajectory so as not to travel too close to this gigantic structure. After all, the consequences it could have on our interstellar journey are unknown. Now that we've reached cruising speed, I suggest you take in the scenery. Look out into the distance. The stars are covering the cosmos in all their glory. you have the privilege of admiring an area of space that is home to a huge cluster of galaxies. Meet the Giant Arch. With its crescent shape, this grouping extends over 3.3 billion light-years. Distant from our galaxy by 9.2 billion light-years, it is one of the largest structures ever observed. Made up of galactic clusters, galaxies, and abundant amounts of gas and dust, it stretches across nearly 1/15 of the observable universe. To give you an idea of its scale, the Giant Arc, if visible to the naked eye from Earth, would represent, despite its remoteness, almost 20 times the width of the full moon. If it was only discovered in 2021, it's because such a structure, according to established models of the cosmos, isn't supposed to exist. According to the Standard Model, the current theoretical limit predicts that the size of a structure should not exceed 1.2 billion light-years. And yet, the 45 to 50 galaxies in the Giant Arc are bound together by gravitational forces, as in any galaxy group. It was therefore detected by chance, while a scientist named Lopez was assembling maps of objects in the night sky using the light from 120,000 quasars. She then realized that the specific signature of certain halos from several dozen galaxies was similar. Mapped in 3 dimensions, the structure discovered turned out to have this atypical arc shape. To assess the probability of galaxies forming such a vast alignment in space, the scientists used 3 different statistical methods. All of them showed that the hypothesis put forward was not all that fanciful. The discovery of this gigantic galactic arc calls many things into question, but it's not the only one to baffle astrophysicists. The Great Sloan Wall and the giant GRB ring, with respective diameters estimated at 1.38 and 5.6 billion light-years, are 2 other unlikely groupings already observed. The Great Wall of Hercules Corona Borealis, visited a little earlier, remains the largest known structure in the universe, totaling 10 billion light-years, whose existence also continues to raise many questions. With our eyes immersed in this ultra-large structure, we've completely forgotten about our surroundings. Let's take a step back and look at the Giant Arc's surroundings. What do you notice? Isn't there another imposing structure looming in front of you? In this same region of the universe, close to the constellation Bouvier, another grouping of galaxies forms a gigantic ring of light. But unlike other circular structures, this one resembles a helix, taking the form of a complex spiral. While this unusual appearance is striking for any seasoned observer, its dimensions are once again beyond comprehension. This colossal structure, with a diameter of around 1.3 billion light-years, has only just been detected. The announcement of its fortuitous discovery was revealed, also by Alexia Lopez, at the 243 meeting of the American Astronomical Society, which has just taken place at the start of 2024. The Great Ring, as this new structure has been christened, is almost similar in size to the Giant Arch discovered 2 years earlier. If this structure could be opened up into a curved shape, its circumference would equal the length of the Giant Arch. To get a better idea of the ring's gigantic size, consider that if it were visible to the naked eye from Earth, it would cover the night sky like 15 full moons in a row. In addition to their extraordinary dimensions, i.e. in excess of 1.2 billion light-years, the theoretical size limit, these two giant structures also raise another question for cosmologists. Given that the giant arch and the Great Ring are located in the same region of the cosmos and at the same distance from Earth, is it possible that they are connected to each other? In short, that they are part of the same, even more extraordinary cosmological system? These latest discoveries add up to new evidence that compromises our current understanding of the universe. Once again, the cosmological principle that matter is homogeneously distributed throughout the universe may well be proven wrong. Shouldn't scientists start examining this possibility? Shouldn't they shatter what they once believed to be irrefutable, i.e. all manner of theories and rules governing the laws of the universe? Crazy as it may sound, many scientists say they're ready to consider it. But before they can do so, they'll need even more convincing arguments. For this, new research in the direction of as-yet unexplored objects or structures, which are consequently very difficult to detect, will have to provide new tangible proof. However, another argument is also being debated by astrophysicists. Some so-called impossible or early galaxies tend to confirm that the cosmological principle may well be obsolete. Thanks to new observations by the James Webb Space Telescope, scientists have discovered almost half a dozen galaxies that appeared just after the Big Bang, displaying unexpected characteristics. To everyone's surprise, these galaxies are so massive that they could call into question their very origin. Joel Leha, professor of astronomy at Penn State, announced that instead of tiny galaxies, they had detected disconcertingly massive ones. These turned out to be as mature as the Milky Way in a region of space then considered the dawn of the universe. The galaxies studied show a redshift, appearing to be approximately 13 billion light-years old. Admittedly, according to scientific consensus, our universe was born some 13.8 billion light-years ago. But that means they would have reached maturity in just a few hundred million years after the Big Bang. The idea is simply inconceivable according to the standard cosmological model. These luminous groupings of stars are so massive that they are impossible in 99% of models of the early universe. What's more, they are astonishingly small, adding to the mystery surrounding them. So how do we explain their existence? How can galaxies from the early universe be in such an advanced state of growth, corresponding to billions of years of cosmic evolution? For the researchers, there had to be a mistake. Although every effort was made to locate it, it could not be found. Could it be that galaxies were formed more than 26 billion years ago? That's what Rahendra Gupta, assistant professor of physics in the Faculty of Science at the University of Ottawa, suggests. For this scientist, our universe could actually be twice as old as current estimates. This would not only shed new light on those impossible early galaxies, but also provide an explanation to the existence of stars like Methuselah, the stellar Doan that seems to have been shining longer than our universe. Rahendra Gupta is the originator of a new way of thinking and explains how his model stretches galaxy formation times by billions of years. In this hybrid model, he combines the evolution of Paul Dirac's coupling constants with a controversial theory, Zwicky's tired light theory. According to this theory, the redshift of distant galaxies is due not to the expansion of the universe, but to a gradual loss of photon energy. The photons would be progressively stripped of energy as they traveled the very long cosmic distance to the observer. As for Paul Dirac's coupling constants, these are fundamental physical constants that govern the interactions between particles. These may have changed over time. To sum up, according to the synthesis proposed by Professor Rahendra Gupta, the redshift exhibited by these incredible galaxies could be attributed to two phenomena. One is the expansion of the universe, the other is the fatigue of observed light. For the scientist, our universe could therefore be exactly 26.7 billion years old. The distant universe fascinates astrophysics experts and enthusiasts alike, all the more so when our Earth is hit by one of the most energetic cosmic rays ever recorded. Named Amaterasu, this strange cosmic ray was detected on May 27, 2021, by the Array Telescope Network. With its unrivaled power, it surpassed the first phenomenon of its kind detected in 1991, named Oh My God, and which motivated the Telescope Array project. Over the past 3 decades, more than 30 ultra-high energy cosmic rays have been detected, but none of them reached the power displayed by Oh My God until this latest discovery. Nicknamed Amaterasu after the Japanese goddess of the sun, this cosmic ray, composed of accelerated particles, is baffling scientists for several reasons. The first, of course, is its extraordinary power. The kinetic energy of just one of these particles has been estimated at that of a tennis ball thrown at nearly 150 kilometers per hour, or 90 miles per hour. While this ray, invisible to the naked eye, has remained in the shadows for the average person, it did not fail to panic scientists' measuring instruments when it was detected in the Utah desert. But even more disconcerting is the fact that nothing seems to be at the origin of such a phenomenon. Neither our galaxy nor neighboring galaxies. Indeed, after tracing its trajectory, the researchers were able to trace the source of this cosmic ray, or so they hoped. After all, it seems to come from a region of our universe that is virtually devoid of galaxies, and therefore relatively poor in matter. So how do we explain this flow of atomic nuclei and high-energy particles? What mechanism could have generated this extraordinary cosmic ray? Once again, to explain Amaterasu's origin, everyone has their own hypothesis. For some, it could have been particles emitted from our galactic surroundings, an event sufficiently discrete that no energy release or gamma-ray burst is detected by our instruments would then be the origin. This hypothesis calls into question the distant origin of the cosmic ray. A second theory suggests that the cosmic ray was deflected by an extragalactic magnetic field much more intense than originally thought. But the energy of the particles is so high that they should not have been affected by any magnetic field. Finally, the last hypothesis raises the possibility that this particle could confirm physics unknown to the standard model of particle physics. Critics also suggest that the Array telescope may have overestimated the energy of the cosmic ray. What's more, the exact nature of the particle detected is still an unknown factor that can change everything. Is it a proton? Or, for example, an iron atom? As in so many other cases, this discovery only adds more mystery to our universe, which is proving to be ever more complex. One of the most recent discoveries once again challenges our understanding of the cosmos. A team of astronomers from the U.S. Green Bank Observatory, led by Karen O'Neill, has just made an unprecedented announcement. A unique galaxy, christened J0613+52, has just been spotted. What's special about it? It has no visible stars. So the image we have of a galaxy as an immense grouping of luminous stars bathed in gas and dust is not always accurate. So say the astronomers who have just inadvertently pointed their telescope in its direction. The discovery, which was totally fortuitous, was due to an input error. As Karen O'Neill explains, an operator inadvertently set the Green Bank telescope to the wrong coordinates. Without this oversight, the object 270 million light-years from Earth would have remained in the shadows, and with good reason. It's a low-surface brightness galaxy, which is extremely faint, even for this type of galaxy. Aware of this parameterization error, the astronomers nevertheless decided to take a closer look at this structure, which at first glance seemed insignificant. Their curiosity paid off, enabling them to make a completely unexpected discovery. They soon discovered that unlike other galaxies with low surface luminosity, this one is particularly rich in gas. Its chemical signature suggests that it contains abundant quantities of primordial gas. Like spiral galaxies such as the Milky Way, it contains mainly hydrogen and helium. After measuring the wavelength shifts, an undeniable fact emerged. This galaxy seemed to rotate in the same way as an ordinary spiral galaxy. This gas cluster has all the characteristics of our own Milky Way. Its mass, composition, and motion all match, except for one thing. There are no stars in this vast gaseous region. Scientists have a new enigma to solve. Have they discovered one of the first primordial galaxies, which underwent no transformations during its 13.8 billion years of existence? Why didn't this galaxy, so massive and holding these elements formed shortly after the Big Bang, enrich itself, like its counterparts, through stellar explosions in the course of its evolution? For Karen O'Neill, the gas in this structure is too diffuse to allow it to collapse in on itself under the influence of gravity. What's more, this galaxy is totally isolated from any other structure in its immediate vicinity. It seems never to have been disturbed by any other galaxy. But these explanations are not enough to demystify this unique and fascinating recent find. Indeed, it's unlikely that over such a long evolutionary period, no gravitational force has ever disturbed its peaceful existence. And yet, this is what it seems to demonstrate. To better understand the nature and dynamics of the early universe, scientists will have to be patient. Future discoveries of cosmic bubbles that have not undergone any reshaping should help elucidate this anomaly, but they still need to be detected, as they are particularly discrete. Now it's time to return to our magnificent planet Earth. Let's plan our return. However, there's one last anomaly we'll need to overcome if we're to return in the best possible conditions. Our trajectory must absolutely avoid a vast zone located between South America and the southwest of the African continent. You may not know it, but this area is known as the South Atlantic Anomaly. It turns out that in this region covering the globe, a curious phenomenon has been intriguing scientists for several decades. The intensity of the Earth's magnetic field is unstable and much lower than in the rest of our planet. If we were to cross this zone, the consequences could be terrible for our spacecraft. Bombarded by high-energy particles emanating from our sun, all onboard technology could suffer interference, or even worse, a disastrous malfunction. But rest assured, this phenomenon, although unexplained, is not new, and we know perfectly well how to dodge it to bring this fantastic voyage to a close.